So this one, if you look at this, is the last slide for chapter 4. Basically, the end game for Fourier transform is circuit analysis using Fourier transform. So basically what I have taught you since the beginning of chapter 4 is towards answering the circuit analysis. Okay, and you are going to use Fourier transform. And for information, okay, we have still yet assessment. Few assessments have not been done yet. I only gave you quiz 1, right? Quiz 1, which is chapter 1. Quiz 2 and 3, not yet. I believe not yet. So quiz 2 will be covering chapter 2. So I'm going to give you later on, which is related to final exam lah. Means that convolution integral. Okay, so but maybe not in class quiz. It's just a like take home assignment and you submit it as a quiz. So duration maybe not 1 week but only 1 day. Okay, so very fast lah. Means that a quiz only 1.5 marks, I think, or 2 marks. So 2 marks means that very little. Okay, and then quiz 3 will be Fourier series. Okay, Fourier series, same thing. I'm going to give you instruction in you learn and going to submit it within 1 day. Okay, and we still have 2 more assignment for Fourier transform. Okay, this chapter and assignment 3 for Fourier for Z transform. So I have not yet upload the assignment 2. So this is assignment 2 basically. Okay. So I do not want to give you the assignment yet because I haven't teach you the analysis of Fourier transform for circuit analysis. So if I give you this and then you just like shock because it's circuit. So I don't want that to shock you. So you learn it one by one, and towards the end of this chapter, then only I'm giving you assignment 2. So maybe by this week, assignment 2 will be out and deadline will be next week. Okay, so 1 week lah duration. Okay, so I'm going to continue from Thursday class last week. So we stopped this one, example 7, So example 7, okay. Okay, open up example 7 that we have done last week. But means that I'm not going to buy you so maybe that you can't because we only have 2 weeks before final exam. If I go and buy it now, then it's like the CP drop. Right? So anyway, I'm not going to buy you. Okay? Give you a chance to give it yourself. So basically, please study and give one effort for the final exam. Because especially get 1/40, people who are. If 1/40, then further, you are going to study much more. Right? If not, you're going to notice that you are not your student. In start, what year last semester, maybe the last semester student. Okay, especially those for last semester, taking only this subject, one of the subject that they will take for this last semester. So make sure you don't fail. If not, you're going to extend. That's because of the semester. Okay? So Okay, so we are going to continue this example 7. So basically, if you look at, if we recap again what we did on example 7. So you're given the you're given x and h, yeah? X and h. So that diagram is not given basically. So let's imagine if you are given ht, xt. So normally you are going to find what is yt. Okay. So make it practice. Let me write out in terms of this block diagram. When you get a question, because in the analysis you will need this type of block diagram later on, so that you won't get the wrong equation. Okay, so in this question we are given xt. Okay. We are given xt, and then you also are given ht, right? So if you are given, then you need to find what is y. So based on this, write first the equation for y. Okay. So yt is equivalent to, if you learn the control subject, you know that yt equivalent to ht convolution with xt. And if you remember the two, we do convolution in time domain. Time domain. Right? So in time domain, you cannot simply multiply the signal. But that's the beauty of in a Fourier transform, we can actually convert it into fixed domain. So conversion to fixed domain, so we are going to convert it using Fourier transform. Ft is Fourier transform. So you get y omega equal to if omega multiplied by x omega. So basically what you do is that you need to convert become x omega, and you convert ht become h omega. Alright, so we did that on Thursday. Okay, I'm going to use the Padlet since at least there's a recording that you can look back later on. Alright, so based on what I have written in front, so this is h omega, okay, and y omega. So basically, did I convert it yet? Oh no, Alright, so now what you need to do is that you need to convert it into frequency domain using what? Using Fourier transform. Okay, so using Fourier transform, you will get this one. A bit slow using tablet in front very fast. So you get x omega, ht you get h omega. Okay, so if you look at this equation, how do you convert it? Okay, we are going to do conversion basically using Fourier transform table. The easiest, because it's like Laplace nah. Okay, Fourier transform, direct transform. The two chapter behind is most of the time is using the table. So don't go and derive it. Okay, so where's the table? So table for continuous time Fourier transform. If you look at the equation is given by 3e minus tut. So you need to compare in the table. So which one that you're going to use? Equation number 1. So equation number 1, I'm going to take that. Oh, it's already here. Okay, question number 1. Okay. This one, So this is basically, it can be vice versa lah. Okay, you can actually swap it in between. This is time domain. This is frequency domain. Okay, so basically later, not only you are going to do Fourier, you are going to use the Fourier transform to get from time domain to frequency domain, but you also will be using the same equation when you want to do conversion from frequency domain to time domain. Means that basically you have this one to this one is a Fourier transform, and vice versa is inverse Fourier transform. Okay, but using the same equation, same table. Okay, so if you do a comparison, what do you get for H omega? So you have H omega. Okay, you need to compare one by one. Compare one by one. So you have 3e minus e. The equation given is e minus e. I'm going to do this because something that you might not get at Fourier here. So basically, you're going to compare the main equation with what you have. So from here, when you compare, this is the same. What else is the same? E is the same. So minus E, E. So basically, you have A value. Okay. So what is A value? A equal to 1. So what happened to 3? So basically, how we write the equation is that like this: 3e minus e u. It's just a. Okay. So if you look at the Fourier transform table, then you get 1 over a plus j omega. Okay. So if you take this out, what do we get? 3. And then we're going to combine, means that substitute a value, so you get 1 over 1 plus. This is how to substitute that. So do h omega and x omega. Convert that. It means that sorry, this one is not his. X omega h omega. Okay, so what do you get? You get 3 over 1 plus j omega. Okay, and h omega you get 2 plus j omega. Okay, anyone who couldn't understand how the conversion was done? Anyone? Okay? And depan ni okay? Guys? The Indian student? Okay? Belakang? Okay, Zulis 1. Okay. Apa nama Acap. Acap okay. Okay. Ain kat belakang? Okay. Lupa nama. Siapa nama you? Waiz. Siapa namanya? Wafi. Wafi. Haziq. Danish. Okay. Alright. Girls in front. Girls. Okay. Alright, now after you have do the conversion, what you do is that you are going to continue from what you have y omega. Okay, so y omega is equivalent to h omega. Is it okay this slide? Okay, because this slide projector is big. So x omega. So substitute the value of h, x and h. Okay, so what do you get? 3 over 1 plus j omega. Okay, x, sorry, terbalik lah. Sorry, I read terbalik. Okay, so h omega is 2 over 2 plus j omega, which is this one, Okay, and then x omega is substitute here. Okay, so you get 3 over 1 plus j omega. So expand it, 6 over 2 plus j omega, 1 plus j omega. Remember, the question is for you to get y in terms of time domain. So basically, you are trying to solve y in terms of frequency domain first. Then after you get what is y omega in frequency domain, you are going to use the inverse Fourier transform to convert it back to time domain. So the aim is most of the times is to get the answer in time domain. Okay, so for you to actually solve this, okay, you cannot convert directly this one. Abraham, what's wrong? Calculator? Okay. Okay, so how you're going to solve this is that you're going to use partial fraction, Partial fraction. So using partial fraction, okay, you're going to expand y omega, you get a over 2 plus j omega plus b over 1 plus j omega. This is the common partial fraction. If you have two denominator underneath here, okay, this is a denominator. If you have two numerator in terms of the factoring, then you're going to use partial fraction. Okay, so anyone remember how to do partial fraction to get a and b? Okay, so for a is what? You take the numerator on top here. Okay, this is the numerator. Okay, you write first the numerator a equal to 6. Okay, and then you are going to cross it. Okay, so 6 over 1 plus j omega, whereby j omega equal to, you take this value, j omega equal to -2. So how do you get that? -2. So basically what you do is that you take this one. Okay. Okay. 2 plus j omega equal to 0. J omega equal to -2. Okay. So that's where you insert -2 inside here. Okay. So solve it. What do you get? 6 over 1 plus -2. What you get? 6 divided by? Can I? No need to press calculator. No need to press calculator. Hello. Okay. Okay, anyone okay with it? So basically, you're going to substitute, okay, this one you get 6 over 1 plus j omega, whereby j omega equal to minus 2. How you get minus 2? You take this out, and 2 plus j omega equal to 0, j omega equal to minus 2. So this is whereby you get minus 2. Then you're going to substitute j omega with minus 2. So basically, you have 6, 1 minus 2, you get minus 5, so minus 6. Okay, so do next for B. Find what is B. B value using partial fraction. So B you get. I give you 30 seconds to do it. 30 seconds. B. For those who already done it. Then, everybody done? Who completed B? Raise your hand. So what do you get? B equal to 6. So let me just confirm. So basically you are going to take 6 over, cross it down here. So you have 2 plus j omega, whereby j omega equal to minus 1. So substitute 6 over 2 plus minus 1. You get 6. Okay. Less than 30 seconds, right? I need 5 seconds only to write it out. Okay. So then what do we do? Now we are going to substitute A and B, okay, into y omega. So you get y omega, A equal to minus 6. So you have minus 6 over 2 plus j omega plus 6 over 1 plus j omega. I would normally do a bracket like this, okay, so that you don't get confused. Okay, make sure always to do a bracket like this. So in bracket 2 plus j omega, 1 plus j omega. So this one would be the answer in terms of frequency domain. If you answer this in the final exam like this, then you get marks for frequency domain. Now, you need to actually convert it to time domain. So, conversion to time domain, you're going to use inverse Fourier transform. So, whereby using the same equation in the table, so you get yt. Okay, now compare the same thing. So, what was the equation in the table? So the equation is given by E minus AT UT. Okay. And then you have 1 over A plus J omega. Okay. So right now what you're looking at is this one. Okay, because we want to do a conversion. Okay, conversion to the time domain. Okay, so same way how you do it. If you get confused, then take out minus 6 first in front. 1 over 2 plus j omega plus 6 1 plus j omega. Okay, I'm doing this step by step so that you don't get confused. But if you don't need to take it out, then it's okay. Just directly do convert it to time domain. Now this equation is similar. Oh, bangun tidur ke apa? This equation is similar to the Fourier transform table. So now you can see that A is actually 2 here and A is actually 1 here. Okay, so you have here, this is A, this is A. Okay, then you can write it as minus 6E minus A is what? 2 where? 2T U T plus 6. Okay, E, what is A? 1N minus T U T. So this will be the answer in time domain. Any question? Any question? Yes? Teruskan apa? Exponent. Oh, okay. Yes, can? Means that you want to make it in terms of factorial, eh? So you can rewrite the equation as, okay. Alright, we can write it as 6 E minus T minus E minus 2T UT. Also can. Both get marks. Same marks. If you answer this, marks also this marks. Okay? Right? Any more question? Right? Okay. So let's look at another, the next slide. So basically in this slide is that similar to in the past. So basically you can write it in terms of differential equation. So if you write it in terms of equation, you can do it as summation of yt equal to summation of xt. So let's look at example. Okay. Okay, let's look at this example 8. Okay, so consider a stable LTI system. LTI is linear time invariant system, the one that you learned in chapter 2. Okay, system characterized by a differential equation. So basically given by dy over dt plus ayt equal to xt. So the question here asks you to find the system response in terms of frequency domain and time domain. So frequency response, directly you know that they ask you to find h basically. So in frequency domain means that h omega. Okay, time domain is in ht. Right? So how we are going to use this is that we are going to use the Fourier transform table. Okay, Fourier transform table. If you look at this table, okay, this one, okay, you can see that this is under property, property of Fourier transform. So you can see that there are t to the power of n ft over dt. Then you get the Fourier transform as j omega power of n f omega. So basically we are going to use this transformation So how you do it is that we are going to compare one by one with this table. So you have, so the solution is, write first the equation dy over dt plus ayt equal to xt. So if you look at this equation, what is the n here for differential equation? 1, right? So 1. So directly if you substitute 1, what do you get? You have j omega only. So how you write it is you are going to write it directly here, means that we are going to use the Fourier transform table. So we write it as dy over dt as j omega y omega. Because here n here is equal to 1, right? So when you have 1 here, means that you have j omega f omega. F omega, why? Because the equation given by ft originally means that basically they give you dft over dt. So f omega, it is depending on the question, f ke, x ke, y ke, and so on. Right. So plus ayt, y, normally just convert only. So you have a y omega, equivalent to xt, just convert it as normal, you get x omega. So looking at this example, what they ask actually? They ask you to find HT. So basically HT, you know, is actually the block diagram, kan? The block diagram. So HT here, right? The block. And you can see that in your equation you have y and x. So just draw it out. So you have xt, yt, therefore in terms of frequency domain you have x omega, h omega, y omega. The question asks you to find h, right? So in order for us to find h in the time domain, we need to find first h in the frequency domain. So basically the steps is find h omega first, then next is h t. So h omega, the equation can be written as x times h, right? So you have x omega times h omega. Therefore h omega equivalent to y omega over x omega. So what we're going to do, we are going to rearrange it in terms of h omega here. Can you follow? Is it too fast? Too slow? Too slow maybe, so what we are going to do is that we are going to factorize whatever that we have on the x omega side. So y omega, we have j omega plus a equivalent to x omega. H omega, what is it that we write just now? H omega is y over x. So where is your y? Y over x. So basically, we are going to bring this to the bottom side, right? So we can write it as y omega over x omega, whereby this is h omega. So this one, we bring it down here, cross, okay? So you have 1 over j omega plus a. Have the answer. So this one will be the answer for frequency domain. Frequency domain. Okay. Now, how do you find in terms of time domain? So what you need to do is that you need to use the inverse Fourier transform. So what's the answer? E minus AT U T. So this one is the answer for time domain. Before we go to analysis, let's do one example. Okay, done Okay. So, of course, in my slide, there's the answer lah. But anyway, you might not know which one, how to do it. Okay. So let's do this exercise. Okay. So exercise 4. Consider a stable LTI system characterized by the differential equation. Okay. So you have the power of yt dt plus mod dy over dt plus dyt equivalent to dyt 3x over dt plus 2x. So the question is same question just now asked you to find H in terms of frequency domain and time domain. So first step, what do? Convert first. Okay? Convert first this one, okay, in time domain to frequency domain using the differential equation with some table properties. Okay? So using this one, so try to do it. Try to come up with the equation. just write it down this in terms of j omega in bracket for 2. That's all. And y omega. Okay? Means that for dy squared over dt, what you get is j omega power 2 here, right? So you have 2. So this one is 2. Yt become y omega. So this is the conversion. And then the rest I believe you can do it. And after you have done that, then try to separate out and get h omega. Okay, so the parts right now, get the equation for the differentiation in h omega. H omega is y omega over x omega. Basically, this one will get something like this now. Y omega in bracket blah 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 blah. And then you have x omega in bracket. Okay. Then you're going to write in terms of omega. Okay. So basically, because we want to have it in terms of y over x, so this one break down, this one break down, and this one leave it. Okay, so you get y omega. For example, if this is A, this is B. Okay, so y over x omega, you get B over A, right? Whatever equation in here, right? Okay. Cross across. X omega. answer. You want a break first? Break ah. Habis ni kan. Break. Come back at 12 eh. Okay guys, let's continue. Right, so for the solution, make it a normal practice to write again the equation given. Okay, so you're going to write again d squared yt over dt plus 4 dy over dt plus 3yt equivalent to dx p over dt plus 2xt. I noticed that there are some students that do it one by one, means that you take out this one equation 1, 2, 3, 4, but I think you are going to waste time. Okay, so if possible, directly convert it into Fourier transform in terms of frequency domain using Fourier transform table. So write it beneath the top equation. So you get this to the power of yt dt, you get j omega to the power of 2 y, don't forget you have y here, y omega, okay, plus 4 is just amplitude, take it out, then you have j omega y omega plus 3y omega. Okay, correct so far? And equivalent to, we have the right side, dxt over dt. So like I said, xt, yt, ft, mt is just an equation. So when you look at the table, of course the table say that ft, so you get ft, convert it, you get f omega. Okay, in terms of this dxt over dt, you will get j omega x omega plus 2x omega. Okay, if you notice that the way you write in terms of time domain, yt xt is all small cap, yt xt all small cap. When you convert it into frequency domain, okay, frequency domain, basically you're going to write it into capital y omega x omega. Okay, it's just a symbol so that you don't get confused. Okay, now what you are going to do is that you are going to actually factorize, take out y omega and x omega. Why? Reason why is that the question asks you to find h omega. So like I said, just draw out first. So the question asks you to find HT. You have XT, YT. If you notice that I keep on drawing this, means it's important lah. Important. Important. If you student asks, what's the tip for final exam? This is all tips for final exam. A hint, small hint that if you do it, you write it out, then marks will be given. Okay. So basically, it asks you to find HT. So you're going to find first H omega, because why? If you want to find YT in terms of time domain, you know that you need to do convolution integral, right? Which is difficult. So in Fourier transform, we make it easy. Okay, convert it into a frequency domain. So you're going to get it in terms of H omega, X omega, and Y omega. Okay, so H omega can be written as, what's the equation for H omega? H omega equivalent to Y omega over X omega. This one no need to memorize. Just draw this block diagram, write out all the symbol YT, XT, HT, then get the equation for YT equal to HT multiplied by XT. Then you can find H omega. Okay, don't need to memorize it. Okay, because you have lots of things to remember. So this type of equation, easy way is that to draw out the block diagram. Okay, because some student might do silly mistake whereby they write H omega as X omega over Y omega. So basically wrong lah. Okay. So this is why I keep on drawing the block diagram, so that you actually embedded in your brain, okay. So what we are going to do is that we are going to factorize Y omega. So Y omega J omega squared plus 4J omega plus 3 equivalent to, take out X omega, J omega. Okay, so what you're going to take out is this one. Okay, this one for J omega. So you get X omega, J omega plus 2. We want it in terms of H omega. So therefore, okay, H omega equivalent to Y omega over X omega. Okay, so which one that you need to take it down? So basically you want to stay Y omega here. X, bring it down. So this one is fixed. J omega over here. So J omega plus 2 over J omega squared plus 4J omega plus 3. Okay? Everybody got the answer? Okay? So, as you know, for Fourier transform, the previous example, you see that for answer in terms of time domain, you need to do partial fraction, right? So what you need to do is that you need to factor out the denominator down here. Okay, this one, denominator. Write it again in terms of J omega plus A value. So you're going to write out J omega. Using your mathematical understanding, you no need to press calculator. No need to press calculator. So make it in terms of 2 bracket J omega, You have 3 and 4 here. So I will say 1 plus 3, you get 4. Okay, so this is positive. That's the factoring. I don't know how you learn it, but this is how I learned it before. Because my time, we don't have calculator, advanced calculator. We have that, but this one is simple factoring, and that students should be able to do it. Okay. So now it looks like you can do the partial fraction. Okay, so partial fraction, you write it as A over J omega plus 1 plus B over J omega plus 3. So find A and B. Okay, find A and B. Okay, exercise 1 minute. Find A and B. Same way that we did just now, the partial fraction method. Same way. Okay, if you notice, you learn already control one, right? You learn in Laplace, right? Or last time also you learn Laplace. So basically, if you notice, in Laplace, J omega is equal to S lah, basically. Okay, so if you write it out, it will get S plus 1 plus B S plus 3. Same way. Okay, if you're confused J omega, then just change it to S, but don't forget to change it back to J omega. Okay, because we are not answering Laplace, we are answering in terms of frequency domain, which is Fourier transform. Okay, so A, what do you get? So how do you write, how to get A is that you take out the numerator on top here, so you write it as J omega plus 2 over cross, remember cross, so you get J omega plus 3, whereby J omega is equal to minus 1. So just substitute. Minus 1 plus 2. Minus 1 plus 3. 1 over 2. Don't need to press calculator. Don't need. Just leave it 1 over 2 is okay. No need to change it to 0.5. Okay? No need to change it. Just leave it there. Okay, B. Same way, J omega plus 2 cross J omega plus 1. J omega plus 1, whereby J omega equal to minus 3. Substitute minus 3 over plus 2, divide by minus 3 plus 1. You get minus 1 over minus 2, you get 1 over 2. Okay? So, substitute it in this. Okay, so you're going to substitute 1 over 2, 1 over 2. Therefore, H omega equivalent to A. Just now, I'm just going to write the full equation. A J omega apa? Plus 1 or 2? Plus 1 Plus 1 plus b over j omega plus 3. Therefore, 1 over 2 j omega plus 1 plus 1 over 2 j omega plus 3. H omega, this is the answer. Do you get it? So this one is in terms of frequency domain. Okay? Everybody got it? Okay, now the question also asks you to find in terms of time domain, so it's easy, right? Easy. So how do you do it? So basically, you're going to convert it into time domain by using the inverse Fourier transform. So HT 1 over 2, take it out if you are confused. So 1 over 2, 1 over j omega plus 1 plus 1 over 2, 1 plus j omega plus 3. Okay, so you get 1 over 2. A is 1 minus t ut plus 1 over 2 e minus 3 t ku t. You can leave your answer like this if you want. This one is okay, but if you want to go ahead and factorize it, you can do that. 1 over 2 e minus t plus e minus 3t u t. Same thing. Okay, so both will get marks lah. Okay, if you do this is marks also. Do this is just extra. Sometimes if you do this wrong, then I'll just close my eyes and mark above. Alright, so this answer will be in time domain. Okay. Next exercise. Maybe this one do try to do on your own at home, but let's look at what they ask. Okay. So in this question is that consider this system example form, which is the one that we just did. Okay. So the system is given by HT. Okay. So consider system given in the previous exercise. So you can read like that also. Means that in question A, asks you to find HT. Then B, given this, find another signal. Okay. So for this case is that you already have get the answer both for H omega and also HT. Now the question says that suppose that the input signal is given by E minus T ut. Okay. So find what? Simple. Okay. So basically what it asks is that now we have in terms of time domain is we have MC convolution with HT. But we already know that make it easier to calculate for the output, we are going to convert it into frequency domain. Okay. H omega equal to x omega plus 1 j omega plus 3. Right? So this is h omega. So you need to actually convert x. This is xt. So you need to convert it into time domain. So what do you get? The answer is very easy. So x omega equal to 1 over j omega plus a. What happened? Right? So you have here 1 over j omega plus 1. If you look at this one in numerator, you have the same equation. So we write as j omega. Okay. Then you need to use multiplication. So a over j omega plus 1 plus b j omega plus 1 squared plus c j omega plus 3. This one is easy. This one is difficult. Okay? But we need to refer to how you convert the table, Fourier transform table. So basically, to get a value, okay, a value, so how do you calculate? If I want to write this out, B and C first up is easy. So B is equivalent to j omega plus 2, j omega plus 2, divided by j omega plus 3. Thereby j omega equal to minus 1. B. Alright? C is 1. So we are going to take out j omega plus 2 divided by j omega plus 1 for j omega equal to minus 3. Okay. For A, E over dt. What is the equation? How will you do this? Because we have this one, right? Okay. So we have j omega plus 2, j omega plus 1 by j omega minus 3. Okay. This is mathematics. If you have two equations, for example, you have this one is u, this is v. Okay, I remember during undergraduate, we have these two equations, u over v, v over dt. How do you, what is the equation? What is the equation? I can use the spot there so you can still remember the equation. It's v du over dt minus u dv over dt over v squared. Okay. In mathematics subject, supposedly mathematics engineering, they are you're learning differential equation. Okay. You have like how to actually differentiate specific type of equation. Okay, so you're going to get it in terms of this. So in the end, try to do this. I'm not going to do it. Okay, try to do it. The final answer, you can write it down. Is it in the notes? Okay. This one, Okay, this one is the final answer. Okay. So basically, if you look at this, y omega you get a is equal to 1/4, b is 1/2, and c is minus 1/4. Okay. Then after you get that, I just simply just convert it back to the time domain. Okay, using inverse Fourier transform. Okay. I thought you will see. This one is A. So this one is correct. A equal to minus 1. Okay. Because this is A. Okay. Normally we do A, B, C, right? Because this one we do in class, so I was referring to this one. So J plus 2 is the numerator over this one, because you have the OBT, this is squared, so we have this one, and A omega is equal to minus 1. Okay, so trying to answer and get, should be that A is equal to, if you look at this answer, A will be 1/4, B will be 1/2, C will be minus 1/4. Okay, then don't forget, because the question asked you to get in terms of time domain and convert it back because we transform, then you get the answer. Okay. So this one will be an exercise for you guys. Okay. Now it's 12:30. So let's look at. Now we are going to go into the circuit already. Okay. So this one is just similarly same thing like what I've actually done in the previous exercise. So look at example 9. Okay, you're given a circuit. Okay, for the series RL circuit should be low, since you have a resistance and inductance. Obtain frequency response of H omega t. It specifically asks you to find H omega equal to VR over V. Means that VR is the voltage across resistance over V omega, which is over the input voltage. So I specifically asked you. So basically, what you need to do is that you need to come up with the equation. Okay? Equation of circuit analysis lah, in terms of time domain first. What we have done in circuit 1. Once. Then, based on H omega, then you're going to solve for VR using what you have calculated in A. Okay, so for this example, okay, I'm not going to go. Okay, the important part that you need to take note is that important part that you need to take note here is this. Starting from this page 60, this is all revision of circuit theory and control. Okay, because why I took it from control notes and nice, nice name of the author, NISE, okay. So this one is taken from nice, the table. So basically in nice, you can actually write out the capacity resistor inductors in terms of whatever value dt for capacitor, resistance, and inductors. Okay. For current voltage, you do like this. For voltage charge is this one. What we are going to refer to most of the time for Fourier transform is only on the impedance side. Okay, so meaning that for capacitance, the voltage across capacitance will be written as 1/CS. Since this one in nice, book they are using Laplace. So most of the equation original is 1/CS as in Laplace. So basically we can write it in terms of Fourier transform, which is this capacitance, the force, the voltage across capacitance will be 1 over C J omega. So just substitute the value. So meaning that if you have a resistance and we have inductance also, capacitance. Okay, so capacitance. So basically in this case is that you can have the voltage across the resistance, which is VR. So you write it in terms of impedance, you write it as ZR. Okay, for the capacitance also the same thing, you're going to write it in terms of the voltage across capacitance, which is VEC. Okay, but we are using the impedance. For Fourier transform, we convert it into impedance because it's easy for us to do the calculate summation. So we are going to convert it into ZR. So this one, in terms of impedance, ZC. Okay. So ZC, BC, the impedance is given by 1 over CS, which is in Laplace, and we are going to just convert this from C J omega. For resistance, direct. There's no value, so if you have a value, VR is equal to 2, then you get ZR is equal to 2 only. Okay. If we have another one which is inductance. Okay. So you have BL, so you write it as ZL, and based on that is LS, KS, substitute with J omega, you get LJ omega. L, C, and R is basically, a value. The value of the resistance. For example, resistance value is 2, then this is equal to 2. The capacitance value is 2. So you write this one as 1 over 2 J omega. If the inductance value is 3, then you write it as 3 J omega. Total impedance over this loop will have Z total equal to ZR plus ZC plus ZL. So take this, you have R plus 1 plus 2 J omega plus 3 J omega. So this is how you directly use it. Because if you are using it in terms of voltage current, you can see that you have a integration and so on. Okay, so we do it in this way. Okay, most of the time because we are going to use V equal to IR. Okay, common value. And the next slide is all about, you can just do some revision if you forgot about circuit. Okay, so this is just some equation or some equation that you have learned in circuit theory. Okay, circuit 1, that is important. That I believe it will be useful for you to be for the Fourier transform. So series resistance, parallel resistance, summing circuit, okay, voltage divider rule, okay, loop, analysis of loop, and so on. So I'm going to skip this because this is revision. So we are going to go directly to example 9. Okay, so example 9. Hopefully we can finish it. Okay. Okay, so the question asks you, Okay, obtain the frequency response of H omega. So just write that H omega equivalent to BR omega over B omega. So since we know that we need to find what is BR, then we are going to use the equation BR. Okay, so A, okay, H omega equal to BR omega over B omega. Okay, using Kirchhoff voltage law, okay, V equal to IR. Okay, so we are going to find what is BR omega. BR omega is equal to I, okay, omega. Okay, we are writing it in terms of frequency domain directly, okay. So I omega multiplied by R, right? R just now, remember we change it into impedance. So multiply by Z R. Okay. So this one, I'm going to write it as ZR equivalent to what? Look back at the table just now. This table. Okay. R. What is the impedance for in terms of impedance Z? Get R value. Okay. So and you can write it I omega. If you have I, can you write it in terms of B over R? I omega is where? I is this one, right? Which is this I lah. So I omega. If you write it, you can write it as B omega equal to I omega times the impedance. The total impedance, right? Total impedance. Okay. So let's say that, okay, having said that, we are going to write I omega in terms of B omega over ZT. Okay, so I omega, we write it as V omega over ZT times ZR. ZT is Z total, means that over the loop lah, the whole loop lah, one loop. Okay. So now we need to find first what is ZT in order for us to actually substitute the value, right? ZR, direct. ZR is equal to 2. So ZT is what? ZT, oh, this one. ZT equal to ZR, since we have only resistance and inductance. So ZR plus ZL. So ZR is the value, okay, 2 plus ZL, the equation is given by, if you have inductance, LS. In terms of Fourier transform, L J omega. Okay, so what's the value of L? 1, So you have, if I write it out, you have L J omega. So basically you have 2 plus J omega. Okay, so this is ZT. Why I write Z like that with because I'm scared I confused with 2, 2 and Z. My handwriting is almost the same with 2 and Z. So that's why I normally write with Z with the label. Okay. So what we do is that we are going to substitute ZT here. Okay, this one. substitute there. Okay, what do you get? So V omega over 2 plus J omega. Now you can substitute ZR. ZR is 2. Only the value, right? Okay, so times 2. Okay, if you rearrange it, you have 2 over 2 plus J omega B omega. What was the question? The question asks you to get in terms of VR over V omega. Do you have those two right now? Yes, right. You have here V omega, and then you have VR omega. So, therefore, okay, H omega is equivalent to VR omega divided by V omega. So, VR is where? Here. Okay, VR, V omega here. Okay, V omega here. Okay, so just rearrange it. Okay, so what do you get? You get 2 over 2 plus J omega. This will be your answer. First one only, eh? Any question? Okay, B. They ask you to solve BRT and IRT if BT is given by 10E minus 3T UT voltage. Okay, so this one, what you can do is that directly change it to Fourier transform to frequency domain using Fourier transform. So you get V omega equivalent to, cepat, apa dia punya equivalent in frequency domain? 10 over J omega plus 3. Okay. Okay, right now we try to answer first VR. Because VR we have already the equation. Okay, VR. So if we rewrite the equation for VR, VR T, we convert it first to VR omega. Okay, convert it first. Okay, because they ask you to find it in time domain, basically, but we are in Fourier transform, so convert it first to frequency domain. So convert it first to frequency domain. So do you have the equation from the previous A value, VR? Have, right? Okay, so based on this equation, this one, okay, H omega equivalent to VR omega over V omega. You are given V omega, which is here. Do you have H omega? Yes, based on the previous A. So can you get VR? Yes. Okay, so therefore VR omega equivalent to H omega times V omega. Can follow? Any equation je, you need to know the basic equation V equal to IR, and then find, and then rearrange it, and then you get the answer. Okay, so the question, again I repeat, the question asks you to solve for VR, so means that find VR lah. Okay, so right now we already know that the equation for VR equal to H omega times V omega. So do we have equation for H omega? Yes, based on the previous exercise here. Okay, H omega is this one. So just key in 2 over 2 plus J omega times, what is VC? VC is the one that you just converted. 10 over J omega plus 3. In final exam, maybe you have 2 looping or 3 looping. Your assignment 3 looping. This is only 1 looping. Okay. So since they ask you to find VR in time domain, so what you do? Using partial fraction. So try to get what is the value. A plus 2 plus J omega. A pula. Betul lah. Okay, this one you get 20 over 2 plus J omega. J omega plus 3. So you get A over 2, so, not A, J omega plus 2 plus B over J omega plus 3. So what is A? What is B? Okay, let's I compete with you. Who finish first? Okay, 20 over J omega. Don't look at me, look at your paper. Plus 3J omega equal to minus 2. 20 divided by minus 2 plus 3. So you get 20. 20 divided by J omega plus 2. J omega equal to minus 3. 20 divided by minus 3 plus 2. Okay, done. Not done yet. Should be done now. I just did it just now, within 5 seconds maybe. Okay. So you will get your answer VR omega equivalent to 20 J omega plus 2 minus 20 over J omega plus 3. Of course, the answer need to be written in terms of time domain. Then you get 20 E minus 2t ut minus 20 E minus 3t ut. Okay, or you can write it out E minus 2t minus 2t minus E minus 3t ut. Answer. Okay. Are we finished yet? Not yet. We need to find IR. IR is simple. V equal to IR, right? You have VR. Okay. You have IR just now. Okay. So to find IRT, okay, use equation VR equal to I R omega times Z R. Therefore, I R omega equivalent to VR omega divided by Z R. What is VR? This one. So 20 divided by VR apa? 2 eh? 2, right? 2. Okay, so E minus basically it asks you in terms of time domain eh. Okay, sorry. Same thing lah basically eh. Same thing. So because you ask in time domain, directly time domain, so B RT equivalent to IRT times R. IRT equivalent to BRT divided by R. BR is above 20 divided by 2, E minus 2T minus 3T U T. So you get 10 E minus 2T minus E minus 3T U T. The answer for IRT. Okay. I don't think you need to take a photo in the slide ada solution unless you don't actually print my slide or download my slide. That's about it Okay. So okay. Easy. Okay, so this is example 9. Of course, you need to do it. Okay, example 9, its solution is inside here, but so many, so long. So try to do exercise 6 in terms of inductance, 500 millihenry. Okay, past year 7 and 8, past year question. Okay, try to do at home on Wednesday class. Wednesday class, we are going to discuss this. But I need you guys to actually try to come up with the solution. The solution is not in my slide lah. So a tip that you can use here is that use current divider. Use current divider rules. This one. Okay. So where to do revision? This one. Go to the list of revision that I have shared to you. Current divider rules. This one. Is it here? Maybe no. Okay, but it's in the final paper here. Current divider rule. So if you have an example like that, so you can. Okay, using that, then you can try to get the answer. So we will discuss this on Wednesday. This week we have class on Wednesday. Okay. Or Tuesday and Wednesday. Tuesday and Wednesday. So and maybe by today I will upload the assignment 2. So deadline to submit will be next week. Okay, and by I think on Tuesday we'll be covering this exercise. So on Wednesday we will go into the last chapter, Z transform. So make sure that you print. If you are using hard copy, print out my notes. If you are using your tab, download the notes. Okay, that will be all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.